Hey guys, Mrs. Young here. Time to go over our Chapter 6 study guide for our upcoming test. So we're going to start out with looking at the Earth and the Moon and the tides. So the Earth. So we have a definition here of the rotation axis is the imaginary line on which an object rotates. So in our case, it's the imaginary line that runs from the North Pole to the South Pole. So we have rotation is a spinning motion. The length of rotation for Earth is 24 hours. So that is responsible for day and night. Okay, so you're going to need to know that. We've got two words that are very similar in sound, rotation and revolution. So day-night is rotation on its axis. Revolution is the motion of one object around another. So for us, the length of revolution is 365 and a quarter days. That quarter days is what adds up to leap year we're experiencing this year. So that is 1 year, the length of revolution. So the motion is counterclockwise and will spin from west to east. West to east. So then the objects in the sky are going to appear to move east to west, which is why we have our time zones and we have people over on the East Coast, like New York City, are having the sunrise 3 hours before someone like my daughter living in Seattle has it, because it is the east side of our country is turning into the sun sooner than the West Coast. The moon. Why do we see the moon? Well, we see the moon only because the sunlight reflects off of it. It does not emit its own light. It is not a star. It does not have nuclear fusion. We don't emit our own light, so planets and moons do not, but only stars do. So the length of rotation and the length of revolution is the same. That's called synchronous rotation. So they are in sync with each other. They're rotating once around us and then once around on its axis in the same amount of time, which is why we see the same side of the moon all the time. We never see the far side. We only see the near side. So what does the moon revolve? Well, it revolves around Earth. So the structures that we have on the moon, when we look up there, we have Maria. So those are those large, dark, flat areas on the moon. So they are formed when lava flowed up through the Earth's crust and solidified in the craters that were formed. So it's now hard, cooled lava is what these Maria are. So craters we have from impacts from space objects banging into us millions of years ago. So we have tides. Tides are the daily rise and fall of sea level. So if you have ever been to Florida, you know that if you are there in the morning and you put your chair out by afternoon, if you put your chair out near the water, by the afternoon, your stuff is wet. So we have two special tides. We have the spring tide and we have the neap tide. So it's mainly the moon's gravity that is responsible for the moon's gravity is responsible for the tides. But we have a couple of times during the year, during the month, where the sun helps to either accentuate and make larger that tide or diminish. So one of them here is the spring tide. Let's make this color. Okay, so this is one. The sun and the moon's gravitational force combine to produce higher than normal high tides and then therefore lower than normal low tides. That's going to happen on the new or full moon. So if we have a straight line, remember what I asked you to remember is we've got spring, straight, supersized, super high tides. Therefore, our low tides are going to be lower because that water is going to our high tides. So spring tides, the sun and the moon's gravitational force combine to supersize that high tide. Therefore, then where there are low tides, it's going to be lower than normal low tides. That happens on the new and the full moon when the sun and the moon and the earth are all in a straight line. So we have sun, moon, earth, or we have sun, earth, moon. But either way, they're in a straight line and they work together to supersize that high tide. All right, so then we have another type. We have neap tides. So what I want you to remember here was our 90. Remember that? Okay. Let's cut that. We have the sun and the earth and the moon form a right angle and the gravitational force is reduced. So this is going to be our first quarter and our third quarter moons where they form right angles, and they kind of offset each other. So what I asked you to remember here is neap is going to be 90 and not so much. So not so high tides. So if our high tides are not as high, it's going to leave more water in with our low tides. So sun, earth, and moon form right angles and the gravitational force is reduced. Lowest high tides and highest low tides. So lowest high tides because they're kind of working against each other and minimizing the tide. So not so high tides, therefore leaving more water for the low tides. So that's first and third quarter does that. So the force mainly responsible for all of this is going to be the moon's gravity. So then we have some solstices. We have the idea of seasons and solstices and equinoxes. You are going to need to know this graphic. Okay, so when we look at this graphic, you were to label the summer and the winter solstices and the vernal and autumnal equinoxes. So whenever you look at a picture like this, what you have to orientate yourself with are going to be the tilt. Always start at this point. So we need to look. This is tilted toward the sun. So that is going to be our summer solstice. We know in the northern hemisphere, when the northern hemisphere is tilted toward the sun, then that is summer. Look at this one over here. This is tilted away. So that is going to be winter. It's tilted away from the sun. This one is tilted toward the sun. So the summer solstice is going to be that one day. This is going to happen on June 20th, 21st, where the sun is going to be highest in the sky, and it's going to be our longest day of the summer. There's lots of festivals that go on. It'll be light, like 15, 16 hours or so. It's wonderful. And it signifies the first day of summer. So then fast forward 6 months from then, we are most tilted away. So it is going to be where the sun is going to be lowest in the sky. On the summer solstice, it's highest on the sky. With the winter solstice is going to be the point where the northern hemisphere is most tilted away from. Our sun position is going to be lowest on the horizon at that point. That is a really short daylight day. It is going to be the shortest, like right around 8.5 hours or so. So then what we're approaching here and we are watching is the approaching of the vernal equinox. The spring equinox is going to happen about March 20th, March 21st, where we've gone from the longest day of the year, daylight day, the shortest day of the daylight days, and right here is when we are going to have equal day and night, and that is going to be our equinox. And we are watching that as we are monitoring our sunrises and sunset. We're seeing how we are getting more and more and more daylight hours. So then halfway between winter and summer is vernal equinox, first day of spring. Halfway between summer solstice and winter solstice is our autumnal or fall equinox. So we go from the longest daylight day. Summer solstice around 16 hours. This is around 9 hours. So we get to the point where we have to have an equinox because we are going from the longest day heading towards the shortest daylight days. So halfway in between there, around September 20th or 21st, we'll be at our 12/12 equinox. So we're going to go ahead and stop this video here, and we'll pick up on the second one.